Okay guys, welcome to a physics tutorial. Today we're going to be looking at projectile motion. So first thing we should do is actually read the question. So it says, Chantal likes to make potato launches. She fires a potato straight up and times how long it is in the air. It's in the air for 10 seconds before it lands next to her. The first question says, draw a picture and use a kinematic equation to calculate how high the potato went. Hint, the potato rises for the same amount of time as it falls. What will the velocity of the potato be at its highest point? So the first thing we should always do is label the known variables. So the first known variable that we know is that time is equal to 10 seconds. Put a unit there. And then we know that, right, let's draw the picture next actually. So the potato goes up for 5 seconds, and it comes down for 5 seconds. And what's that force that's making the potato go up? It's gravity. And gravity, we can put it down as acceleration due to gravity is equal to 9.8 meters per second negative 2. And then the last variable that we know is the final velocity. The final velocity is just the velocity of the potato when it's on the ground. So that would be 0, of course. So VF, so that stands for final velocity, is equal to 0 meters per second. Okay, now we need to calculate the distance, how high the potato went. So if it's only high, that means it goes up for 5 seconds. So we'll be using 5 seconds instead of 10 seconds. So looking at the kinematic equations and seeing that distance, there's one that's really easy. It's distance is equal to final velocity, so VF, times time, so T, minus half of acceleration times time squared. And we can easily just substitute the values here. So we know that VF is 0, and we know that time here is equal to 5. So 0 times 5 minus, minus, I'll just put it in brackets so it's easier, half of acceleration, so 9.8 times 5 squared. And that's just gonna come down to 0 times 5 minus, gotta put a negative there because the force is going down, so it's negative 9.8. So it's just gonna come down to negative 122.5. And that is just 122.5 because negative times negative and 0 times 5 is just 0. So it goes up 122 meters, 0.5. Okay, next question. Chantal then wonders what the initial velocity of the rocket is as it leaves the barrel of the gun. Use a kinematic equation to calculate the initial velocity of the potato. So again, let's label the known variables. So we know that final velocity is 0 meters per second. We know that acceleration due to gravity is negative 9.8 meters per second squared. And we also know time, which is, again, we're using 5 seconds because, yeah. Now if we look at the kinematic equations, the one that fits the most here is V, because we're trying to find the initial velocity. So VF equals VI plus acceleration times time. Here we're trying to find VI. So what we need to do is rearrange the equation. So we simply subtract AT from both sides. So it's gonna end up being final velocity minus acceleration times time equals VI. And we can simply just substitute. So VI is equal to 0 minus negative 9.8 times 5, which will just end up being VI is equal to 49 meters per second. Okay, onto the second to last question. So I'll move along here. It is, Chantal wants to see how far she launches the potato. Benna explained if she wants to shoot the potato, the greatest distance the gun should be fired at 49 degrees to horizontal. Chantal wonders if the potato will be in the air for more than 10 seconds for it to travel so far. Calculate how long the potato was in the air when fired at 45 degrees to the ground level. Hint, use the initial velocity to calculate NB and SOHCAHTOA. So first thing we need to do is draw the trajectory of the potato. So let's say the potato launcher is here and it travels at an angle of 45 degrees. So let's say beta here is 45 degrees. We know that the initial velocity is 49 meters per second. And just with this information, let's draw up the trigonometry triangles. So we have SOH, which is we have CAH, and TOA. And now what we should do, before that actually, we should have labeled the triangles. Label the triangle. So we know that this is the hypotenuse because this is the longest side of the triangle. And since it's a 45-degree angle, both of these sides will be the same. So actually you can just draw a line here indicating that they're the same. So that means that the length here, this length, will be the same as this one. So it doesn't matter which one we pick. So this is adjacent and this is opposite. So I'll just use sin here. So if we look at the triangle, we know let's figure out, let's say, the opposite. So let's go over here and try the triangle. So sin here is equal to 45 degrees. 45 degrees. And the hypotenuse is equal to 49. So let me draw the triangle here. And we're trying to find O. So basically, this triangle here is telling us that O is equal to 45, well, actually, my bad, sin 45 times 49. So if we put that in a calculator, it will give us 34.6. And that's the side lengths of this triangle. So this is 34.6 and this is 34.6. Okay, we figure now this is the first step. Next step is figure out timing. Now that we know the variables, so we know initial velocity, we can find a formula. So the most suitable kinematic equation here is VF is equal, so here we're trying to find time. So let's label all the known variables. So we know that VF is equal to 0, VI is equal to 34.6, and what's the first one? Acceleration due to gravity equals negative 9.8. And that next thing, now let's look at the kinematic equation. The most suitable one here is VF equals initial velocity plus acceleration times time. And we're trying to find time here. So what we do to rearrange here, we subtract VI from both sides. So it's going to be VF minus VI equals acceleration times time. But we still only want time. So what we're gonna do now is divide both sides by A. So it's going to be VF minus VI over A, because you're dividing both sides by A to get rid of it, equals time. And now, if we just substitute this equation, it should be 0 minus 34.6 over negative 9.8 equals to once again equals to 7.06, and that's how long it takes for the potato to travel that far. So 7.606, so t is equal to 0.06 seconds. And now the last question is, assuming the potato, that the horizontal velocity of the potato is constant, calculate the greatest horizontal distance that the potato can travel for a length. So this is really simple. Just change in distance equals just 1 second. Okay, so if we look at the triangle here, distance. So triangles in physics are your best friend, ST. This is the triangle for distance, because we're trying to find out distance. So since it's distance here is equal to, so D is equal to speed times time. So if we just simply substitute a value, D is going to equals to 34.6 times 7.06, which equals to, D equals to 244.276 meters. And yeah, that's the distance, and that is the tutorial. Thank you for coming. Hope you could understand this, and yeah.